So far, we've used angle, sum and difference identities to turn a trigonometric function of a sum or difference into a sum of a product, or actually a sum of multiple products. It's actually possible, with a bit of cleverness, to go back the other way, to get an identity that takes a product and turns it into a sum. Now this is useful. For example, if you want to differentiate or integrate this, it would be much nicer to have a sum than to have a product. Or for another example, graphing. Much easier to graph this than to graph this. So if we can get rid of the product, sometimes that's very helpful. How does this work? Well, we've already got these two identities, sine of a sum and sine of a difference. If we add them together and work right to left, the other way around, if we add them, these two terms are going to go away, and I'm left with two lots of sine x cos y, which means two lots of sine x cos y is sine x plus y plus sine x minus y. You might also see it as sine x cos y is half of this thing. Because there's half of a sum, you need brackets, so it's usually written with the 2 out the front. Conversely, if I subtract them, I'll end up with a slightly different expression over here. Actually, this expression and this one are really the same thing. All we've done, see here we've got sine x cos y, and here we've got sine y cos x. If you swap x and y in here, the only thing that changes is the plus or minus sign of this sine term, which just means it's going to be minus if you have them the other way around. So you can learn two identities, or you can actually learn only one. They're really the same thing. Also, we've got the sum and difference identities for cos. They look like this. Now, if I add these, the sine terms disappear, and I'm left with 2 cos equals cos of the sum plus cos of the difference. Alternatively, if I subtract these two, I'll end up with 2 sine is cos of the difference minus cos of the sum. Depending which way you get it, you may end up with a negative 2, and then you just swap those around to get the positive 2. So here are 4 identities that will help you to turn a product into a sum or difference. And again, as usual, these identities are actually on your formula sheet. Interestingly, notice they've actually written it with the half version. And I think the reason is the syllabus says you have to be able to prove and apply the identities for products of sines and cosines expressed as sums and differences. So they've actually written it for that conversion from products to sums and differences.